Okay, this is the video, the data collection video for the equipotentials laboratory. In this experiment, we're going to be mapping out electric fields on a two-dimensional surface produced by a power supply. Okay, so I'm going to take the data, and I'm going to upload the data for you to use to do an analysis, as we've been doing all semester. So let me go through the equipment for this lab. There is this apparatus here, which I'm going to describe to you in a second, for measuring, for producing an electric field over the space, over the two-dimensional space, over this surface here. Okay, I have a power supply. Let me move the camera. So I have a power supply here, which basically produces the electric field. I'll put a voltage across the two ends of the apparatus. There's two ends to the apparatus. I'm going to put the voltage across here, and that voltage will produce an electric field on this surface that I'm going to map. Okay. I have a galvanometer. The galvanometer measures the voltage difference between this point. So I'm going to slide this wand over this surface here, and the galvanometer will measure the potential difference between this point here, this point right underneath the screw, and one of these points where I'm going to connect the other end of the galvanometer. Okay, so if the galvanometer is connected here, there'd be, the difference in potential between here and here, right, or between here and here, will be measured on this screen, which you can't see, but you'll see it better when I put a piece of paper down, because right now the contrast is not right. Okay, so that's the galvanometer. It's going to be connected to this equipment, and this power supply is connected across here. Okay, so in order to produce the field, what I'm going to do is I'm going to choose a field plate. Okay, I'm just going to do this for one field plate because we have a limited amount of time. So I'm going to use this field plate, which will basically set up a positive charge on one side, a negative charge on the other, and there'll be a field between these distributions of charge. Okay, basically here's the plate. Okay, the plate is going to be let's see, the plate is going to have positive charge on one end and negative charge here, and there'll be a field produced between those charges that we're going to measure. We're actually going to measure the equipotential curves and use the equipotential curves as described in the handout to find the electric field lines. Okay, so I'm also going to use a piece of paper that I'm going to put on here, and that piece of paper is where I'm going to actually draw the equipotentials, and then you are going to draw on it, on top of it, the electric field lines, using the equipotentials as guides. Okay, so let's put this all together here. So I'm going to turn this over like this, and I'm going to place my field plate on this surface. Okay, and I just want to check to make sure my template is the correct template. So it's not, actually I'm going to do it this way around, because that's how it's going to work right. So I'm going to put my field plate like that. Okay, I'm going to screw this in place. Okay, to keep it firmly in place like this. I don't want to do this too hard because I don't want to ruin the surface. So basically, all of this black area is a conductor. These white areas are where the charges are going to be. Okay, so I'm going to turn this over. Now keep in mind, right, this line charge is going to be on this end. Okay, so I'm going to put a piece of paper down. I'm going to put a piece of paper and I'm going to hold it in place with these spring-loaded doohickeys here so that it doesn't move as I'm taking data. Okay, so those are going to keep the piece of paper in place. While I take data. Okay. In order to know where exactly the charges are, I have this template. And that didn't work right, did it? So this needs to go like that. So I need the line on this side. So I'm going to turn over my my plate because I want the line on this side. So I'm going to turn this over and move the line over to the other side. Like this. Okay. Now I have the line charge. The line charge on this side. The line charge on this side is in fact on this side of the paper. Okay. Let me put the paper in place like this. Keep it immobile. And now here's my stencil that shows me exactly where the line charge is on the bottom. So I'm going to trace that out here like this with a pencil. And the point charge, or the circle charge, which acts like a point charge on this side. And now I can remove the stencil. So now you can see an image of where the charges are on this sheet, on the back of the sheet, really. Okay? All right, and this line corresponds to the line back here, and the point corresponds to the point back there. Okay? All right. I really don't want to move the paper once I've drawn the thing in here. So there we have our surface. Okay. Now I want to connect up my apparatus. So I'm going to put 12 volts. So I can set this power supply to different voltages. I'm going to set it to 12 volts. I'm going to have plus 12 volts on this side. Let me move this around a little bit so you can see it. Okay. Plus 12 volts on this side. And my ground, or zero, is on this end. So what I've done is I've produced a total of 12 volts between this point and this point, because this is connected to where this line is, and this is connected to where this point is. So between this line charge and this point charge, when I turn this power supply on, I'll have 12 volts difference. That's the difference in potential between any point on this line and this point here that I've drawn. Okay? So when I turn this on, I will have that potential difference. The next thing I'm going to do, okay, is I want to connect my wand so I can move it around and see exactly what the potential is at any given point. So I'm going to take this wand, and this conductor here is connected to this wire at the bottom, right? This conductor here, when I touch this to the surface on the bottom, it's going to basically measure the potential or measure the voltage at that point. So I'm going to slip this over the apparatus like this. Okay. Now, goes through the galvanometer to measure the voltage difference between the two ends of the galvanometer. One end of the galvanometer, okay, is going to go to the wand. The other end is going to a particular value along here, okay? This whole voltage of 12 volts is divided into 8 parts. So the voltage here, right, corresponds to 1/8 of 12, 2/8 of 12, 3, 4, 5, 6, 7/8 of 12, and then 8/8 of 12 at the very end where the red thing is connected. All right, let me show you again, because I think that maybe you didn't see that on the video, right? So this is 0. This is 1/8 of 12. This is 2/8 of 12, 3/8 of 12, 4/8 of 12, 5/8 of 12, 6/8 of 12, 7/8 of 12, and 8/8 of 12 volts, where 12 volts is the total voltage between the two ends of the apparatus. Okay? All right. So I've connected it to the 1/8 of 12. So basically, right now, the voltage where the wand is, okay, is going to be 1/8 of 12 volts. Wherever I put it, that means it's going to be, this is going to measure 1/8 of 12 volts. Okay, now everything's connected. I'm going to turn on my power supply. Okay, and notice when I turn on my power supply, as I move my wand across the paper, let me move my camera a little bit. Okay, as I move across the paper, notice the galvanometer moves, right? So what I'm looking for is I'm looking for all the places on this surface where the voltage is exactly equal to, in this case, 1/8 of 12 volts. And I'm going to mark those points. If I move in this direction, the voltage difference between the two ends of the galvanometer is not zero. I'm at less than 1/8 of 12 volts at this location. If I move too far in this direction, right, the voltage difference between this point and this point is more than 1/8 of 12 volts. Okay, so I'm looking for the places where I'm at exactly zero, and those are the those points, all the points where I read zero on the scale, are points where the voltage that at that location on the surface is exactly 1/8 of 12 volts. Okay, so I'm going to mark that. I'm going to take a pencil and I'm going to mark that location directly underneath the wand at 1/8 of 12 volts. Okay, and I'm going to look for another point on that equipotential curve. So I'm going to move it down a little bit, and I'm going to move it around until I find 1/8 again. There is another 1/8. I'm going to mark that point with a pencil underneath here. This is not super accurate, but it's, it gives you an idea of where this is true. Okay, I'm going to move it again a little bit down and trying to find a place where my galvanometer reads zero right there. So I'm going to put another point with my pencil right at the location where that was, there. Okay, move it down again, find another location, moving it back and forth until I find a location where I read zero. Okay, and that's right here. Okay, and let's see if there's another one I can find down here somewhere. No, I'm off the paper. There's a point somewhere here, right? There's a point there, so I can certainly mark that one like that. Okay, let's go on the other end. So going up here, let's look up here. Okay, so looking for a location where my galvanometer reads zero, there it is. I'm going to go underneath this wand here, right at that location, and draw a point. Okay, looking for another point. There. Okay, about there. Make a mark there. Okay. Look for another point up here somewhere. Okay, right there. It looks like it's about zero. Well, maybe a little more. Okay. There we go. That's zero. Okay, so here we have another point. Okay, so there's my first equipotential. If I connect these points that I've drawn, this curve is an equipotential curve, and the equipotential curve is 1/8 of 12 volts. Right? That's the voltage everywhere along the line that connects these points. Let me now trace out the equipotential curve for 2/8 of 12 volts. So I'm going to unplug this and plug it here. Now I'm looking for the equipotential where I'm 2/8 of 12 volts everywhere along that line. So putting back my wand, I'm looking for points. Let's look for a point in the middle here. Okay, there's a point right there. Okay, there the galvanometer reads zero. So right underneath where that is, I'm going to put a point. Let me move down a little bit, move it around until that reads zero. There, it reads zero right there. Right? So I'm going to put a point here, move it down a bit more. Okay, there we go. Here, another point. Move it down one more. Let's see, move it back and forth, find the zero. And the zero is right around there. So there we have another point. I wonder if there's another one I can get here. There's another one right there. So let me draw that in here too. Okay, let me go up on the other end. Looking up here, finding the 0. There's a 0 right there. Okay, up here. Moving around again, up here, there is another point where I'm reading 0. So I'll put a point underneath that. Let's look up here. Okay, there's a 0. Put a point there. And try one more. Moving it around. Moving it around. There. Okay, so right where my wand, the tip of my wand is, I'm going to put a dot, right? So here, you can see a second set of points. And these points, if you connect them, are an equipotential with a value 2/8 of 12 volts. Okay? First equipotential, the second equipotential. So as we are moving from this equipotential to this equipotential, we're going up in potential. We're going from the ground, which is down here, to the highest point, which is here, to the highest point, which is on the other end, where the circle is, right? So these are like level curves on a topo map, right? This everywhere along here, you're moving along the edge of this hill. Then you're a bit higher along the edge of the hill, always at the same height. Okay. Now we're going to do our 3/8 of 12 volts. I'm going to unplug here, and I'm going to plug into E3, which gives me 3/8 of 12 volts. And I'm going to look for my, I'm going to look for my equipotential points here on the curve. So let's find the first point. There is a point. Let's see, the galvanometer there reads 0. I'm going to put in there, here. Okay. Moving down a little bit, moving around. There is another one here. Moving down a little bit. There. Moving down a little bit. Finding the 0. There it is. Like that. And that's it. Okay, and then let's go up the other end. So let me go up to the other side of the curve. Looking here, looking for a 0. There is a 0 just about there. Okay, so I'm going to put a point here. I'm going to keep moving up and finding another point right there. Up again. There. And then up here somewhere, there is another, right there. There is a 0. Okay. There. So now I have another set of points. If I connect this third set of points into a line, that's the line, the equipotential, where the voltage is 3/8 of 12 volts. Okay? So first equipotential, second equipotential, third equipotential. Let's go to the fourth one. Unplug this, plug it in here, and do the same thing. Look for the points. Okay, so let's start in the middle here. Move it around until my galvanometer reads 0. There, it's reading 0 there. Find that point directly underneath it and mark it there. Okay. Look for another point on that equipotential curve where I read 0. There it is. Put a point underneath it right there. Moving down again here, I have a point there. Moving down some more. There. And let's look down here somewhere. There's another point. There's a point right here. Okay. Notice this equipotential is starting to curve around a little bit because of this point charge here. Okay. All right. Moving up the other side. Looking for the 0. There's a 0 right there. Up. Moved a little bit. There's a 0 right there. Mark it. Move up. There's a 0 up there. mark it. Another 0. Here, mark that one down. Let's see if I can find another one. There. Okay. There's my third equipotential. If I connect all of these points, this set of points, these set of points are the equipotential with value 4/8 or half of 12 volts. So that's 6 volts. This is the 6 volt equipotential. I want to now look for the next equipotential, the 5/12ths, the 5/8, sorry, 5/8 there. Okay. Let me look for the places where I have that potential. Exactly. So let's start in the middle here. Moving around, there we go. Looking at that point, the galvanometer reads 0. Mark that point right there. Moving it down a little bit. Here, mark it there. Move it down a little more. There. And the curvature is becoming stronger here as we're getting closer to the point charge. Moving it down here, moving it around. I need to move my camera a little bit so you can see what I'm doing. Okay. There. Like that. Moving it down here. Looking at the galvanometer, it's 0 there. Like that. Mark that point. Down here somewhere. The galvanometer reads 0 there. Like that. Let's look at the other end. So going up here. There is my 0 up here. There is my point up here. Moving up, let me make that a little bit darker. Okay. Moving up. Moving around, finding the 0. There it is. Mark it. Moving again. Finding the 0 right there. There it is. Up here, moving it around until I find a 0. There it is. Like that. And then up here, one more, I think. I can get another one at least. So here, as I move it, I find a 0 right around there. Well, that's pretty close to the last one. Okay. Let's see if I can find one more. Maybe I can, maybe I can't. Let's see if it's possible. No, I don't know if it works. Well, yeah, right there. Right there. Okay. This set of points, if I connect them, that gives me my 5/8 of 12 volts equipotential. Let me move this over to 6/8 or 2/3 of 6 volts and look for those points. Okay, so looking around for the 0, there is a 0 right there, right? The galvanometer reads 0 there. Mark that point here. Moving it down, around until I find the 0 right here, like that. Down here, moving it around until I find a 0 on the galvanometer. There it is. Down here, moving it around, there's the 0. There, something like that. And down here, there. Let's see how far I can go with this. There's a 0 right there, more or less. Here. Maybe one more. Nope, that's it. Okay, let's go the other side. So going up here. Nope. There we go. There's a 0 right there, just about there. Mark that point. Moving around, I'm finding a 0 just about there. Mark it. There. Mark it. Maybe one more. Maybe not. Yeah, maybe not. I can't get there, so that's going to be it. Okay, so this curve here, if I connect these curves, this corresponds to my 6/8 of 12 volts equipotential. And finally, I'm going to look at my 7/8 of 12, looking for those points, okay? Let's move around until we find that. There is a 0. Oh, that's tricky. There it is. There's a 0 right there, about there. There's a 0 right there. There's a 0 right here. Moving it around, there, just around there is a 0. So like there, around here, there's a 0 right there, right around there. Going back here, trying to find one back here. There it is. Up here, moving around, no, that's too far, this way. There. Let's go around the other side. No, it's going to work better this way. Moving around, no. There it is. Okay. Here. I'm looking for a point over here. If I can get to it, it doesn't look like my wand can get there. I don't know if I can get another one here. See if I can get to it from this side. There's something in the way on the bottom. No. There it is. There is my last point. No, that's a point I already sort of had. I don't know if I can get a point up here. I probably can't. Nope, I can't reach it. So I'm just going to have to figure out how those points meet. They clearly go in a circle. Perhaps if I went around like this, I might be able to get to it. Let's see if I can do that. No, I can't get to it. So those are all my points. This last one, right, this is the 7/8 of 12 volts. Okay, so your mission at this point, I'm going to scan this thing. So let me show you what it looks like. I'm going to scan this. You're going to connect all the points with smooth curves for each equipotential. So there'll be a curve here that corresponds to one equipotential, a second one, a third one, a fourth one, 5, 6, and then 7. Okay. Those will be your equipotentials. And then you're going to use those equipotentials and the relationship between equipotentials and electric field lines to draw in the electric field lines on this surface, making sure you show the direction and you show the magnitude. Now, this is the minus side, right, because that's the ground. And this here is the plus charge here, because this is the high side of the power supply. Okay, so that's the experiment, and that's it. Okay.